So the question's asking for the zeros of P of M. So I'm taking P of M and I'm going to set it equal to 0. Now I see that the first set of parentheses here is the difference of two perfect squares. So I'm going to factor that to M plus 2 and M minus 2. However, I see that the second set of parentheses is not the difference of two perfect squares. So I'm just going to leave that alone. Now, when we're asking for the zeros, we want to know what the solutions are, what M is equal to. So we're going to do our little T-chart here. And essentially, we're going to take each value, or each factor, I should say, set it equal to 0. I'm going to take that one and set it equal to 0 as well. Okay, so obviously on the far left here, we could have just kind of cheated and changed the signs, but basically what I'm doing is I'm subtracting 2 from both sides, and I get M equals -2. So there's one of the zeros. I can do the same thing with this middle term. I can add 2 to both sides, move that down a little bit, and we would get M equals +2. Now this last factor here, if I set that equal to 0, I would subtract 1 from both sides, and I would get M squared is equal to -1. So if I want to get M by itself, I would have to take the square root of both sides. But look at what happens when I do that. So what I end up having here is I end up having something that is a negative underneath the radical. So that's an imaginary unit. Text message. So since that's an imaginary, we know that that's going to be, oops, let me just go back and there we go. And I have plus or minus, because remember when we take a square root, we have plus or minus, and the square root of -1 is I. So then if you look at the 4 choices, we would have -2, +2, positive I, and -I, which would be choice 4. All right, so with this question, what we're going to do is we're going to circle the base, run the race. So we're going to start by circling that base, which is a 0.8. I'm sorry, that's so small. And we're going to run the race. Now let's just talk about this for a minute here. If you go through and you read the question, it says in the second sentence, the value V of his car after T years can be modeled by that equation. So because it says the value of V, what we're trying to do is we're trying to get the equation to say V equals. And right now, it doesn't say that. So I'm just going to try to circle the base, run the race to get it into a different form so that I can get that V by itself. Okay, so that what I end up with is 0.8 to the T power equals, and then we've got V over 17,000. Okay, and technically this is over 1, so I can cross multiply. So when I cross multiply, I end up with V equals 17,000 times 0.8 to the T power. Okay, so now that I have the V by itself, let's read what it's asking. It's asking for what is the average decreasing rate of change per year of the value of the car from June 2012 to 2014. Now, if you look at this, originally when this all started, it says that Greg purchased the car in June of 2011. So 2012 would be 1 year later, and 2014 would be 3 years later. Okay? Now, because they're asking for the average decreasing rate of change, that's the rate of change formula, which is your slope, change in y over change in x. y2 minus y1 over x2 minus x1, however you'd like to think about it. So basically, I need to find the value of the car in 2014, which is 3 years after he purchased it, right here in June 2011. So the value of the car at time 3 minus the value of the car in 2012. Now, 2012 was 1 year after he purchased it. Okay, over 3 minus 1. That's how you find average rate of change. Okay, so you have a calculator. So all you're going to do then is you're just going to take your calculator and we can put this equation in, and then I'm going to plug in a 3 here, get an answer, and then I'm going to plug in a 1 here, get an answer, and subtract them. Okay? All right. So when I plug in 3, I'm just going to go like this. That's my average rate of change here. I'm going to get 8,704 minus, and then when I plug in 1, I get 13,600. And that's going to be over 2. And then, I'm sorry, I'm trying to squeeze it all in here for you. I end up with negative 2,448, which makes sense because it's a decreasing rate, right? So the rate is going down. That's why we have the negative. And the question says to round to the nearest $10 per year. So this is my tens place. So that's going to give me negative 2,450, which is choice 3. So for number 3, they want the greatest amplitude. Now, if you look at choice 1 and choice 3, those are based upon a graph. So what I like to do to find the amplitude, remember max minus min divided by 2. So for choice 1, oopsie, let's just move that back again. For choice 1, what I'm going to do is I'm going to take the maximum, and I see that occurs right here at 7, minus the minimum, which occurs at 3, and then we just divide by 2. So that would be 4 divided by 2, which is 2. Okay, so the amplitude for choice 1 is 2. Now while I'm at it, let me go over and do 3 because that's going to be very similar, right? Okay, so I'm going to take the maximum, and I see that that maximum is at 3, minus the minimum. Here's the minimum all the way down here. That's at negative 5, so minus negative 5, all over 2. So 3 minus negative 5 is 8 divided by 2, and that's going to be 4. So there's the amplitude for choice 3. So far, choice 3 is the winner. That's not necessarily going to be the answer, but here we go so far. All right, now choice 2 and choice 4, we have equations. So remember, the amplitude is just the number in front of the word sine or cosine. Always has to be a positive value, though. So the amplitude for choice 2 is 3. And then the amplitude for choice 4, be careful, is 5. Amplitude will always be an absolute value, always be a positive number. So then in this case, the answer is choice 4. All right, so there's a few ways to do number 4. I think the easiest way, honestly, is to just use your calculator. So put this in your Y1, and I would just get a picture. Okay, nothing crazy, it doesn't have to be beautiful, but you'll see that your picture kind of looks like that. Okay, and then, let's use a different color here. We'll see that it hits the x-axis at negative 2, so that's one of the zeros, right? Then it also hits the x-axis at 6, and it also hits the x-axis at 7. So let me just make that look a little mathematically more intelligent. Okay, so those are our 3 zeros, which means, remember, if we wanted to make factors out of those, we would just change the signs. So that means we'd have x plus 2 would be one of the factors. Then we would have x minus 6 as another factor. Oops, and I'm sorry, that's supposed to be 7 equals x. And then we have x minus 7 would be the other factor. Now, if you read the question says which one is not a factor. Well, this one is, this one is, and this one is. So it's choice 2. Okay, so for the next question, number 5, it wants you to describe the solutions. So what I would probably do is I would probably start by taking the original equation right here, the first one, and I would get y by itself. So I'm going to subtract 4 over, so bring it over in this direction, and then I'm going to bring the y over in that direction. So what that's going to do is that's going to give me 2x, and then that 4, if I move it over, becomes -4, or -4, equals, and then if I bring the y over, it's a negative now, but if I bring it over to the other side, it's positive. So what that will allow me to do is, now I know what y is equal to, and I can take that and I can plug that in right there. Okay? So I'm going to substitute into the second equation. So the second equation currently has x plus 3, that quantity squared, plus, now there's the y, right? So I'm going to replace that y with its new value, which is 2x minus 4. And notice, though, that that y value is squared. And then we equal it to 8. All right, so now I know that if I have a binomial squared, that means write that twice, and we're going to double distribute. So I'm going to have x plus 3 times x plus 3. Oops. And then plus, I have another binomial that's squared, so I'm going to write that twice as well, 2x minus 4 twice, and set that equal to 8. All right, so all I'm going to do is I'm going to double distribute. So when you double distribute, this is what you're going to get. And then we're just going to add like terms. So if I add the x squareds, I get 5x squared. If I add the x's, I get negative 10x plus 17. Now, I'm getting plus 17 because as much as I did not show this, this 8 here is going to end up coming over there and becoming negative 8. Okay, so plus 17 equals 0. Oh my goodness, there we go. All right, so I really don't feel like factoring that, so I'm going to go ahead and just do the quadratic formula. And actually, that's not going to factor. So x equals negative b, so that would be a positive 10, plus or minus the square root of b squared, so that's negative 10, that quantity squared, right, which would be 100, minus 4 times 5 times 17. And the whole thing is going to be over 2 times 5, right, 2 times a, which is 10. All right, and then we can just look at this. This is the big thing right here. So if you look at this, and you throw that in your calculator, now remember, it's underneath a radical, you're going to get negative 240. And you should know that any square root that's negative would be imaginary. So your answer is choice 1. For number 6, remember that the formula for the total, because this is asking for the total downward distance, would be S sub n equals a sub 1, that's the first term, minus a sub 1 times r to the n, and it's all over 1 minus r. Okay, well initially the ball is dropped from a height of 32 feet, so that would be your initial height. So that's going to be 32 minus 32, and if you read the second sentence, it says it bounces and rebounds 80% of the height from which it was falling. So our r is going to be 0.8. N, it wants to know what is the total downward distance the ball traveled up to the 12th bounce. So that n would be 12. And down here, 1 minus 0.8. All right, well, the rest is history here, guys. Go ahead, take your calculator. You do alpha y equals, throw that all in, and you are going to get 149. So then your answer is choice 4. All right, so for number 7, we did this one in class, and there were some heated debates at points with this one. But if you read the question, it's a little wordy, but it says 264 out of 550 likely voters said they would vote for Mayor Ortega. So if you do 264 and you divide that by 550, you get, I think it was 0.48, right? Yeah, 0.48, which is 48%. Now here's the thing. If you read choice 1, it says there's a 48% chance that Mayor Ortega will win the election. That's not the case. And this one is asking which statement is the least appropriate. So it would be choice 1. And the reason being is if they had said something like, we're estimating rather than his chance of winning, okay, then choice 1 would be the case, and it couldn't be an answer. But because they're saying there's a 48% chance, we can't say for certain that there's a 48% chance. It's an estimate that 48% of the people would likely vote for him. But so that if you look at the other 3 choices, that 48% will make sense for the other 3 choices. So those are true statements, but the one that's a false statement is choice 1. So for number 8, I'm going to show you 2 ways to do this question. So the first way, I'll show you the real mathematical way, and then I'll show you the cheater method. Okay, so I would probably start by, oops, always forget to turn that back. Okay, sorry. So I would probably start by taking this exponent, and I see that I could write that as 1 over 73 point, I can't even read what that says, 83. Oops, I'm going to run out of room here. Sorry, 83. Let's start that over again. Hold on a sec. All right, there we go. So that's how I would write it, as 1 over 73.83 times t. So now what I can do is I know that A is equal to 100 times 1/2, and I can take this part of the exponent and bring it to the inside. So that's going to be 1 over 73.83, and then keep the t on the outside. I'm sorry, that's going to get cut off. Hopefully you understand that that's a t. All right, now I'm sorry that this is also very ugly looking, but what you're going to do is you're going to take this part right here and put this in your calculator. So you're going to do 1/2 to the, and then 1 over 73.83 power. All right? So when you end up doing that, then you're going to get A equals 100 times, and when you put that in your calculator, you end up with 0.99065. And then the t stays on the outside, which would be choice 3. Now that's the mathematical way of doing things. Now I'm going to show you the cheater method, okay? So the cheater method, I would say, would be to take this equation right here, take the right side of it, and plug that into your calculator and store a number in as x. So for example, you take your calculator and do 2 store as x. Now remember, the store button is right above your on button on the bottom left-hand side. So 2 store as x, and then you hit enter. Then what you're going to do is you're just going to type in the right side of your equation, this one right here. You're going to just type that into your calculator exactly as you see it. So 100, open a set of parentheses, alpha y equals, put in the 1/2, close the parentheses, hit the to the button, then do alpha y equals again, and put x over 73.83. Now, when you hit enter, you should end up with, again, remember I stored 2 as x. You don't have to store 2 as x, but that's what I did. So when I stored 2 as x, I got 98 0.1398, blah, 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 blah. Okay? Now what you can do is you can go through these 4 choices, plugging them in one at a time. And again, so for choice 3, for example, I would just plug in this. I've already stored 2 as x, and I should get 98.1398. The other ones, I will not get that, and that's why it's choice 3. So that's the cheater method. Go with that, it's easier. Okay, so number 9. Number 9, if you've read it through, which you should have, it says what proportion of the ball bearings will have a diameter less than 3%. So that is normal CDF. So you're going to do normal CDF. I'm just going to abbreviate normal CDF. Now less than 3.7 centimeters means it can be 3.7 or it could be lower than 3.7. So in this case, the number that we're going to have on this left-hand side right here has to be very small. So we pick a very small number. Okay, doesn't matter what you pick, but you want something pretty small. So maybe -99999. Do you need that many nines? No. But again, you want it significantly lower than the 3.7. Then your upper is going to be 3.7. Okay, then we go with our mean, and then we go with our standard deviation. Now remember, you can find normal CDF. You hit your second bars button, which is above the tangent button. It says distribution, DISTR, in blue. Okay, so you hit that, and you go down to normal CDF. You plug all those numbers in, and you're going to get 0.06680. And you can see that that's choice 1. So, number 10. They're giving you an equation, P of x, it's a degree 3, and it gives you what the x-intercepts are. So what I did was I just sketched the picture based upon that. Whoa, why do I always do that? Okay, so let's try that again. All right, so I'm going to sketch that picture, and I know that x is equal to -2. So I'm just going to go like this, and that's going to be -2. I'll write that in just a minute. And then I've got 10, and I have 14. Obviously, my picture's not drawn to scale. All right, so let's change colors here. So this right here will be -2. This one we're going to say is going to be 10, and this one over here is going to be 14. Okay? All right. So then my picture could look like, maybe we could go down like this, and then we can come back up like that, and then we could go down again, right? That's a degree 3. It has 3 direction changes. All right, so now if I know that my zeros are -2, 10, and 14, remember then if I want to find the factors, I have to just switch the signs, right? So let's switch those signs, and I would get x plus 2. Then I would get x minus 10, right? And I would get x minus 14. All right, so if you read the question, it says which statements regarding p of x could be true. So we automatically know choice A can't be true because those don't match the factors that I wrote. Okay. Now, the other thing that we know can't be true is, look at C. It says the maximum volume occurs when x is equal to 10. Well, this is the maximum right up here, and that's somewhere between 10 and 14. So if that's the case, then we know that that can't be true either, so we can cross that out. Now let's look at choice B. Choice B, let's see. Well, that x plus 2 matches that. X minus 10 matches, and so does x minus 14. Let's talk about this negative. Remember, that's the leading coefficient. And the leading coefficient in a degree 3 polynomial, the way we find that is we go over here, let's look, and notice that our graph is going down first. So that determines whether our leading coefficient is positive or negative. And in this case, since p of x is decreasing, then we know that the lead coefficient is negative. So far, choice B is a go. Now, let's look at choice D. It says the maximum volume of the box is approximately 56. So what I did was I went to my calculator and I went into my Y1 and I plugged this in. And then what I did was second calc max. And that way I could figure out what my X and Y coordinate was of that maximum. All right? So when I do that, I ended up with this point up here was 12.1407. Let's make that look like a decimal. 1407. That was the X value. And then the Y value was 56.28. So you can see then the maximum volume of the box is approximately 56. So that's true as well. So the answer is choice 4. All right, undefined. The denominator equals 0. So I simply just take x squared plus 2x minus 8. Let's set that equal to 0. So I have a trinomial. I'm going to factor that out. And then I'm going to get x plus 4. And I'm going to get x minus 2. A little t-chart here, and let's just cheat and change the signs. So x equals negative 4 and x equals positive 2, which is choice 1. Now, if you remember that undefined means the denominator equals 0, what you could do then is just take your choices and plug them into the denominator and see which ones give you 0. That's the other way to do it. So there's two ways to do this question. We could do the cheater method, and the cheater method would be to pick a number and store it as x. So on one of the earlier questions, I think I used 2. You could pick any number, but I tend to use 2. So if you do 2, store as x, and then hit enter in your calculator, and then all you have to do is type this fraction in your calculator, and you'll get a number. And then you go through the 4 choices, and also obviously you already have 2 stored as x, and then you plug each of these 4 choices in and see which one gives you that same number. Okay, so the answer should be choice 1. So that's the cheater way of doing it. So by cheating, I know the answer is choice 1. Now I'm going to show you the legit mathematical way of doing it, and that would just be by doing long division. So I'm going to take 2x minus 1, and I'm going to divide it into 4x cubed. Now, I notice that I'm missing an x squared term. So remember, when you're missing a term, we write 0 x squared to represent that term that we're missing, plus 9x minus 5. All right. So what do I multiply? Just remember, what we're doing is what do I multiply 2x by to get to 4x cubed? So that would be 2x squared. So I'm going to put 2x squared up here. And then I'm going to take that 2x squared and I'm going to multiply it by both of these terms out here, one at a time. All right, so when I multiply 2x squared times 2x, I get 4x cubed. And when I multiply 2x squared times negative 1, I get negative 2x squared. All right, well, this 4x cubed is a positive, technically, right? So now remember, what we do is we're just going to change all the signs. So I'm going to change this to a minus, change this to a plus. All right. So now I'm just going to add my terms. I see that these guys cancel out, and I have 2x squared. And then I'm going to bring down the 9x. Okay, so let's go back to the beginning again. What do I multiply this 2x by to get to 2x squared? So that would just be an x, right? All right, so I'm going to write plus x. Then x times that 2x is a positive 2x squared. And then that x times that negative 1 is negative 1x. So then we do the same thing that we did the last time. I'm going to circle, change, circle, change. And then I'm going to add. Let me just change my color here. All right, so these guys will cancel out, and that's going to give me 10x minus 5. So then I see the 2x on the outside there. I'm going to multiply that by 5. So that would be plus 5. And then I will get 5 times that 2x is 10x, and 5 times that negative 1 is negative 5. So we can see that if we go through and we change signs, oops, this was a positive, so I'm going to circle and change, those cancel out. So you see that your answer is 2x squared plus x minus 5. So really take some time to read number 13 so that you kind of get a good feel for what it is that they're talking about, what they're asking about. Miles never spun a 6, so he was thinking that his spinner was unfair, so his father did the simulation. Here's the simulation down here, okay? And what his father came up with was, because he's trying to see whether or not Miles's complaint is valid or not. So if you look at this graph that they gave you here, you can see that no zeros, I'm looking right here, this would represent, I'm sorry, no sixes, I should say. No sixes occurred. This is 0 sixes, 20 times out of 100. So let me just go back and change this word because I made a mistake. It should be no sixes occurred 20% of the time. So then we would say, okay, well then the answer either has to be choice 1 or choice 3, because if you read through those, both of them say that that 6 failed to occur in about 20% of the simulations. Now it also asks which explanation is appropriate, so in other words true, so it's got to be 1 or 3. Now remember though, if something occurs 20% of the time, that's out of that 95% confidence interval. So if we're talking about that 95% confidence interval, right, so we're talking 2 standard deviations on either side of the mean, this is my 95% confidence interval. So everything else, which would be out here and out here, occurs less than 5% of the time. Well, this percentage isn't less than 5% of the time. So getting no sixes isn't unusual. It's not statistically significant because 20% is going to fall within that confidence interval. So it's not unusual. So if it's not unusual, then we would say that the spinner is not unfair. So then if the spinner is not unfair, then we're going to say it's actually choice 3. All right, so for number 14, I think the easiest way to do this one, honestly, is just to go into your Y1 in your calculator, type that in, and let's just get a look at what the picture looks like. So basically, the picture looks something like that, okay? And you know, notice that we have 2 zeros. The one on the right is x equals 2, and the one on the left is x equals 1.1303. So now, if you read the question, which binomial is a factor, remember that if you want factors, you take their roots and we change the sign. So this is going to become x minus 2. So x minus 2 is a factor. And you can see that that would be choice 1. So what you want to do here for 15 is you can see that you have a binomial, and that binomial is squared. So remember, when we square something, that means we can take that binomial and we can write it twice. So I'm just going to double distribute. So 3k times 3k is 9k squared. Then I'm going to have 3k times negative 2i, which would be negative 6 ki, and then these guys here will also be negative 6 ki. Then my last two terms, these guys right there, that's going to give us positive 4i squared. All right, now, a couple of things here. I do see that I have like terms, so I can add those. And then the other thing I want to be a little careful of is right here. Remember what I squared is. I squared is equal to negative 1. So we want to take this value here and we want to replace it with a negative 1. So I'm going to have 9k squared minus 12ki, and that's going to turn that into a minus 4. And then if we look at the choices, we can see that that is choice 3. For number 16, you can try to factor that, but you're not going to be able to get anything that's going to add to 2 and multiply to 5. So I'm going to go straight ahead and do the quadratic formula. So x equals negative b, which would be negative 2, plus or minus b squared, which would be 2 squared, which is 4, minus 4 times a, which is 1, and c, which is 5. And the whole thing is going to be over 2 times a, which is 2 times 1. All right, so let's just kind of simplify what's in that radical. And basically, I'm going to get 4 minus 20, right? So 4 minus 20 is negative 16. And we should recognize that that is an imaginary number. So this is going to end up being 4i. So I take the square root of 16, which is 4, and then the square root of negative 1, which is I. Okay, so let me just bring this right back up over here. So then I have x equals negative 2 plus or minus 4i, and that whole thing is over 2. All right, well, now if you look at this fraction, you can see that 2 goes into the denominator, the left side of the numerator, as well as the right side as well. So what we can do is we can divide out that common factor of 2. So if I take a 2 out of here, I have negative 1. If I take a 2 out of here, I end up with 2i. And if I take a 2 out of here, I end up with just a 1. So my final answer is going to be x equals negative 1 plus 2i. And I'm going to break it up, and then negative 1 minus 2i. So those are my answers, and if we look over there, we can see that that is choice 3. All right, for number 17, listen. I would never, ever, if this is a multiple choice, do this one algebraically. Not ever. So much so that I'm not going to even show you how to do it algebraically. If it is multiple choice, then you're just going to take each choice and plug them in and see which one, in this case, if I plug in, the answer, by the way, is choice 2. But if I plug in a 2 here, I will get 16. Okay, let me write that for you. So if I plug in a 2 there, I'm going to get the square root of 16 minus, now let's plug in a 2 over here. So if I plug in a 2 over here, I'm going to get 2 times 2, which is 4, and 4 plus 5, which is 9. So then I'm getting the square root of 9, and let's see if that's equal to 1. Well, the square root of 16 is 4, minus the square root of 9, which is 3, and we can see, yay, that works. Okay? Now, the answer is choice 2. You do want to try 22. Okay? But when you put in 22, just to show you, on that left radical there, 22 plus 14 is going to give me 36, underneath the radical, of course, minus, and then on the other side here, I'm going to get 44 plus 5, right, which is 49. And let's see if that thing equals 1. Well, the square root of 36 is 6, and the square root of 49 is 7. And you can see that's not going to give you 1. It's actually going to give you negative 1. And that's why that would not be the answer. Okay? Don't do it any other way. This is the best way for you to go. For number 18, they ask something about the graph of y equals 2 tan x. So what I did was I went to my y1, and I plugged in 2 tan x. Now, then what I did was I just hit the zoom button, and I went down to number 7, which is trig. And I got a graph that looked like what I just drew, okay? Now, the other option that you can do if you want to get more specific is if you go to Window, your X min, I'm just going to write it like this, your X min could be 0, and your X max would be 2 pi, which is 360 degrees, right? Okay, so if you try putting that in versus then, let's say your Y min could be, I don't know, -4, and your Y max would be +4. The only thing that I would say is that X scale would have to equal pi over 2, because what that does is along your x-axis, look, it's going to give you these slashy things every 90 degrees, because remember pi over 2 is 90 degrees, right? So that's why I make my x scale pi over 2, so that I know when I'm looking at my calculator screen, I know that each one of these slashy things is 90 degrees. So if you're looking at this picture, the directions are only having you look at increasing from 0 to pi over 2. So we're really just looking at this piece of the tangent graph. And look at what happens. It starts at 0, and then it starts to go up. But it's just going to keep going up and up and up and up. So obviously we have an increase, so that's got to be choice 1 or choice 3. But this continues on forever and ever, so that would be an increase without limit. All right, so that's going to be choice 3. All right, so for this question, they're talking about Pedro, and Bobby owning an ant farm. Woohoo! So I started by making 2 equations, one for Pedro, that's the P of T, and one for Bobby, B of T. So Pedro, he starts with 100 ants, so that would be his start amount. So that's going to be 100. And then his farm is growing exponentially at a rate of 15% per month. So remember, that would be 1 plus 0.15. And then per month, I'm going to use T for time. Okay. And then if you look at Bobby, Bobby is starting with 350 ants, so he's got more to start with. And his farm is steadily decreasing. So he's having some trouble there. Decreasing by 5 ants per month. And again, I'm going to use, I don't know why I'm using T, don't ask. I guess I could use M for months, but whatever. Okay, so that would represent Bobby. So basically, if you read the last sentence, it's saying, assuming both boys are accurate in describing the population of their ant farms, after how many months will they both have approximately the same number of ants? So they basically want to see where these 2 equations intersect. Calculator. So what I did was I put this in my y1, and I put this in my y2. All right. So I'll just give you a general idea of what the picture looked like. So this was Pedro, okay, because he's exponential. And then Bobby was more like that, okay? He's linear and he's decreasing, so that's going down. So basically what they want to see is where that intersection point is, okay? And it says after how many months, so that would be my time. So basically then all they want is the x value. So I did second calc, intersect, and I got x equals 8.09, which would be choice 2. For number 20, I started by getting each of these equations to say y equals, because that's what we're sort of used to. And also, if you look at them, all of them have an x squared in them, so it would be easier to get the y by itself. So if I look at choice 1, I notice I could divide by -8, so that would be -1/8 x squared equals y, if I divide both sides by 8. All right, now if I look at choice 2, I'm going to divide both sides by -4. So -1/4 x squared equals y. Let's look at choice 3. Same thing, but I'm going to divide by a positive 8 this time. So that would be positive 1/8 x squared equals y. And then choice 4, I'm going to divide by a positive 4. So that will be positive 1/4 x squared equals y. So we should know that this parabola is either going to open up or down because all 4 of these say y equals. So I think the best thing to do at this point is to draw the picture. All right, so if I draw an xy axis, and it says the focus is at 0, -1, so that would be, let's say, right here, right? Okay, so that point right there is the focus. And the directrix, now it's off my screen, but you can read it, it says y equals 1. So y equals 1 is up here, right? So let me put that in a different color just so that we don't get a little confused. All right, so y equals 1 would be that line right there. Now then what you should know is that your parabola has to be halfway between the focus and the directrix, which would put us right there at the origin, right? And we can't cross the directrix, so that means that our parabola has to open down. Now, if our parabola is opening down, then we know it can't be choice 3, and we know it can't be choice 4, because we should always have a negative then in front of our x squared if we're going to open down. Okay? All right, so we also know that the vertex of my parabola is at 0, 0. All right, the last thing to tackle then would be the p. Now remember, the p is the distance from the directrix to the vertex, or from the vertex to the focus. And you can see that this distance right here, or this distance right here, is 1. So then we can safely assume, whoops, let's get a pen going there, that p is going to be equal to 1. Now remember, the formula is 1 over, in this case, -1 over 4p. So if our p is going to be 1, then this portion of our equation is going to be -1 over 4. And then that would match choice 2. Okay? Now don't forget that the rest of the equation is x minus h, that quantity squared, plus k. But in this case, remember that h and k stand for the x and the y coordinates of your vertex. But since those are both 0, these don't exist, and that's why it matches up with choice 2. All right, so 21's a bit of a bear of a question. There's so much reading involved, and so please, if you have to, just stop me, read the question, read it about 10 times if you have to understand exactly what it is that it's asking and what potentially, for example, this value here, and where's the other one, and this value here represent. Okay, so if you've read the question, basically you notice that they're giving us an equation for a decibel rating. And the decibel rating, you can find, you know, whether something's moderate, loud, very loud, deafening, right here. So we're basically trying to figure out what is our decibel rating. So if you look over here, they give us an I and an I sub 0. So if we read this question, hopefully we will be able to plug in a value for I and plug in a value for I sub 0. So if you read it right here, it says intensity I. Okay? So we know that I stands for the intensity. And then if you read through this, look down here. It says intensity of 6.3 times 10 to the negative third. So this 6.3 times 10 to the negative third represents our value for I. Then we have our I sub 0. I mean, we could use process of elimination. This is it because it's the only thing that's left. But just so that you read this, it does say that I sub 0 is called a threshold sound. And right here it says the threshold sound is 1.0 times 10 to the negative 12th. All right. So if you didn't understand what I just said, rewind me and play it again. okay? But I'm going to try to explain it as I go along here. So again, I'm going to use that equation that I circled, D equals 10 log. All right, now I'm putting in I. Remember, again, I stands for the intensity. And down here it says intensity, right there. So I'm going to replace that I with 6.3 times 10 to the negative third power. Okay? Now, if you look inside that circle, I have right here I sub 0. And they said that that stands for a threshold sound. And it says right here, the threshold sound is 1.0 times 10 to the negative 12th. So all I'm going to do is replace that with 1 times 10 to the negative 12th. All right, so now all I'm going to do is I'm going to try to simplify that fraction because that looks kind of messy. And if I simplify, remember when you have division with exponents, you can subtract those. So let me just kind of give you a little pointer here. So what I can do is I can do 6.3 divided by 1, which obviously is just going to be 6.3. And then these exponents, since I'm dividing, I would subtract them. So let me write that for you just so that you can see it a little bit. So 6.3 divided by 1 would just be obviously 6.3 times 10 to the, and then what I'm going to do, I'm going to just write this off to the side here, negative 3 minus negative 12, okay, which is going to give me 9. So that's times 10 to the 9th. Now, this I can just put right in my calculator. And when I did that, just hit 10 log 6.3 times 10 to the 9th, I got 97.9934. And if you look at this value right here, you will see that that is going to fit into the very loud category, which is choice 3. So for number 22, you're going to have to pardon my drawing, but the other two choices are on the next page, and it was just easier for me to redraw it. So what I did was I just started by doing 13 pi over 20, because that's an angle measure, but it's in radians, right? It says it right there. So I'm going to multiply this by 180 over pi so that I can figure out what that is as a degree measure. So I know my pi's are going to cancel out. I'm going to multiply 13 times 180, get that answer, and divide by 20. So I know that that's 117 degrees. Now, the question is asking which of the diagrams represents that angle of 117 degrees, which we know is in the second quadrant, but that doesn't really, necessarily help us right away. And it says it's drawn in standard position and its reference angle is theta. So let's look at this for a second. All right, I want to point out one thing. Let's look at choice 2 here. Because this angle, you notice all positive angles should start on the positive x-axis and they should go in a counterclockwise order. This one doesn't. This one actually goes in a clockwise order. So this angle that I'm just tracing with my red arrow is actually an angle measure that's negative. And it's an angle measure that's negative and it's more than 180 degrees, which is not what I have here. I have a positive 117. So then, in that case, since that angle is negative, that's not going to be the answer. All right, so then let's look at some of the other choices and see if we can eliminate things. So if we look at this one, well, this looks like 117 degrees to me, doesn't it? But remember, definition of a reference angle is it's the angle that lies between the terminal side and the x-axis. And it has to be acute. This angle theta is not an acute angle. So choice 1, we're going to just cross that one right off the list. All right, then we're going to go to choice 3. Now, choice 3 here, that looks like 117 degrees. But look at this. This is not a reference angle because definition of a reference angle is it's got to be positive, true, acute, true, But here's the problem where it's false. It has to be formed from the terminal side and the x-axis. And this angle is smushed between the terminal side and the y-axis. So we're going to cross that one off the list. Now, obviously, the answer then is choice 4, but I'll go through an explanation anyway, because why not? Okay, here we go again. This is 117 degrees. Look at the reference angle. It is positive. It's acute, less than 90 degrees. And look, it's formed from the terminal side and the x-axis. Bingo. For number 23, I would take the cheater method and plug your answer choices in and see which one or ones work. In this case, there's only one answer per answer choice. Well, except for choice 3 and 4. So if you plug in your answer choices, so for example, the answer is, by the way, choice number 1. So if I plug in a -1, I'm going to plug in a -1 here, and I'll end up getting 2 over 2. Then which is 1. Then I'm going to plug in a -1 here, and I'll get 3 over, what is that going to be, 5, right? So 1 minus 3 over 5, and then see if when I plug in a -1 here, do I get the left side equal to the right? Okay, so that's the cheater method. Now, I'm going to do the real method just in case it wasn't a multiple choice, which it easily could not be. So I'm going to look at the trinomial denominator at the end here, and I am going to factor that. So when I factor that, that's going to be x minus 4 and x plus 3. Sorry, I'm squeezing that in there. That's supposed to be in parentheses. So I notice that my first denominator over here shares a factor of x plus 3 over here. However, look at my second denominator. This is 4 minus x, and this is x minus 4. Those are opposites of each other. So remember, what we said was when you have binomials like that, and they're opposites of each other, all you're going to do is take this sign right here, circle it, change it, in this case, to a positive because it's negative, and we're going to cross this out, and then we can make that x minus 4. So essentially what we're doing is we're multiplying the original 4 minus x by a -1, and then that flips it around and makes it x minus 4. So then in that way, we have this x minus 4 matching that x minus 4. Okay? All right, so now we need to find a common denominator. So let's look at the first fraction. And we notice that this first fraction's denominator is missing an x minus 4. So both the numerator and the denominator are going to get multiplied by x minus 4. Now, hopefully, you can see that these two denominators here, these two factors here, match those two right there. So if you look at this fraction here, you see it's missing an x plus 3 that this guy has and that guy has. So we are going to multiply that fraction then, and I'm sorry, I just have limited space here, so I'm going to squeeze in an x plus 3 there, and then an x plus 3 here. Okay, so I'll just go like that. Now, as ugly and as messy as that looks, you can see that I have x minus 4x plus 3, x minus 4x plus 3, x minus 4x plus 3, and all the denominators, so I just found a common denominator. So the next step, if you recall, is just to take those denominators and say, see you later. So let's look at what I have left. So I'm not going to distribute anything yet. So I've got 2, and I've got an x minus 4, and then I've got plus 3, and an x plus 3, equals, and I didn't multiply the second fraction on the right side of the equal sign, rather, by anything because it didn't need anything. So it just stays. All right, so let's just distribute. So I get 2x minus 8 plus 3x plus 9 equals 2x minus 2. So let's add like terms. I get 5x plus 1 equals 2x minus 2. going to subtract the 2x over. And you know what? While I'm at it, let's subtract the 1 over as well. So those guys will cross out. So I'll get 3x equals negative 3. And if I divide everything by 3, I'll see that I get x equals negative 1. So there's the algebraic way. For number 24, there's actually a few ways to do this question. You can do the cheater method by storing a number in as x, and then just plugging in the original expression and getting a value. And then plug in each answer choice one at a time, and see which of those 4 answer choices matches what you got when you plugged in the original expression. Okay, so again, if you plug, after you've done like 2 store as x, you're going to plug this in to your home screen and you'll get a number. Write it down. And then you'll plug this in and see if you get the same number. You won't. So that's not the answer. So then you plug this in, see if you get the same answer. You won't. Then you plug this in, see if you get the same answer. You won't. So obviously this is the one that's going to take the prize. Okay, so the answer is choice 4. Now, if we wanted to do that, what a lot of people will do is long division. So it's actually going to be, let me just write this, the numerator there, negative 3x squared minus 5x plus 2, that's getting divided by x cubed plus 2x squared. All right, so let's think about this one, because this one's a little bit different than what you're used to. So you're just basically going to ask yourself, what am I going to multiply x cubed by so that I get negative 3x squared? Do you see that my exponent is actually getting reduced by 1? So let's deal with the number. First of all, I know that I'm going to need to multiply by a negative 3, right? So if I want to go from x cubed to x squared, that means I'm going to multiply by a negative 1 power. Okay, so let's just think about this for a second. So then negative 3 times the 1 that's here gives us that negative 3. And then x cubed times x to the negative first. Remember, when you're multiplying, if you have the same basis, you add these exponents. So 3 plus a negative 1 gives me a positive 2. So that works out for us. Okay? All right. So that's going to give me negative 3x squared. And let's just be a little bit careful here. So here I'm going to get negative 6. And same thing here, I'm going to add those exponents. So I'm adding 2 and the negative 1. So that's going to give me negative 6x, technically, to the first power. Now, I'm not going to write the first, but you get the idea. All right. So then, remember, when we're doing this, we just circle the sign, change it, circle, change. So that's going to cross those guys out. And then we just take the other 2 and we are going to add them. So that's going to give me x, and I'm going to bring down the plus 2. All right, so again, we just want to be a little bit careful here, but we're going to do it again. So what can I multiply this by to get x? Now remember, the power here is a 1. So I'm going from a 3 down to a 1. So I'm taking 2 away, if you will. So let me just make sure that I have, I have the right color. All right, so then I know I'm going to have plus x, and that would be to the negative second, because I'm going down 2, so to speak. All right, so let's multiply. So x cubed times x to the negative second. Remember, we add the exponents, so that'll give me x to the first. I'm not going to write the 2, though. To the first, rather. I'm not going to write that. And then 2 times this 1 is 2. And then x, this is interesting, x squared times x to the negative second. Well, the rule is that you take this exponent and you add it with that exponent. And when you do that, you end up with nothing. So that's just going to be plus 2. Okay, now remember, this is technically a positive. So remember what the rule is. We are just going to circle and change, circle and change. And look at that, we're left with nothing. So this is our answer, which matches that. Now the other option that you can do, which I don't think as many kids will do, but what you could do is you could factor this. This is why I think a lot of people won't choose that. And you could factor this, and you could cancel your like terms, okay? I do think that, especially if it's multiple choice, the easiest way to go is store a number in as x, plug in the original expression, get a numerical value, and then plug in your 4 choices one at a time and see which one works, okay? All right, so we're on our first part 2, no cheating here, right? So we can't store a number as x or anything like that. So we're going to do this the good old-fashioned algebraic way. So I'm going to isolate that radical, and I'm going to subtract x from both sides. And that's going to give me the square root of x minus 4 equals 6 minus x. So now, to get that radical by its, well, the radical is by itself. I'm sorry, to get rid of the radical, remember the opposite of taking the square root would be to square. What you do to one side, you do to the other. And remember, this is a binomial squared, which means write it twice, and let's double distribute. All right? So, on the left side, I'm going to get x minus 4. And then on the right side, I'm going to get 36 minus 12x plus x squared. All right, so now I see that I have an x squared, so I'm most likely going to have to factor, maybe do quadratic formula. We'll see. So I'm going to get everything over to the right because that's where the x squared is. So let me move this x over by subtracting it. And while I'm at it, let me move the 4 over as well. Let's just do it all in one fell swoop. So that's all gone, right? So then I end up with, I'm just going to rearrange things so that they're in standard form, x squared minus 13x, and that's going to be plus 40 equals 0. And that really should look like a plus sign, right? All right, well that factors, so that's going to be x minus 8 and x minus 5. They multiply to a positive 40, and that adds to a negative 13, right? And it does say to solve, so solve means, let's do our t-chart, and let's see what we end up with here. All right, so I have x equals 8, and I have x equals 5. So I have 2 values, but please be careful, because these are tricky. You always want to go back and you want to check them in the original equation that was given to you and make sure that everything checks out. So I'm going to go back up to the very original equation, and that had a square root, right? And let's put in 8 where I see an x. So I have 8 minus 4. Then it would be plus, there's another x, so I'm going to put another 8, equals 6. All right, well, 8 minus 4 is 4, right? And the square root of 4 is 2. Plus 8, well, look at that. That's not going to work, is it? So 10 does not equal 6, which means we are going to reject that solution. Let's go over to the right side. Let's do the same exact thing. Go back to the original equation, and now let's plug in 5 instead. Everywhere we see an x. So 5 minus 4 plus 5 equals 6. All right, well, 5 minus 4 is 1, and the square root of 1 is 1. 1 plus 5 equals 6, and bingo, there we go. So our only solution is going to be 5. Well, we've seen this question a lot of times, haven't we? So basically, you have negative 8 and it's raised to a fractional exponent, and they want you to evaluate this and get an answer that's an integer. So I would say, well, I've got power over root here. So 4 would be my power, right? And my 3 would be my root. Now be careful, because it does say to explain, and explain means in words. So you can do this several ways, but what I would probably suggest is you could say something like start by applying the power over root rule and get, and here we go, that's an and by the way, get, here we are. So my root would be 3, and my power would be 4, just like that. Okay? All right, next, I would take the cube root of 8. So next, take the cube root of 8 and get 2. So you're going to have 2 and to the 4th power. Then do 2 to the 4th power, and you will, oops, that's supposed to be an I, sorry, will get 16, and 16 is an integer. So that's our answer. Okay, now you can do it different ways. I'm just giving you one way. All right, explain means in words. You can't just say, oh, I took -8, I put it in my calculator and raised it to the 4/3 power and I got 16. That's not explaining. You won't get any credit for that. Okay, so try to be thorough with your explanation. So we need to write this as a single term. We now have 2 terms, and we want to write it with a rational exponent. So I think probably the easiest way to go about this is to do power over root, like we did on number 26. So I'm going to take the first term there, and I see that that's the cube root. So that means the power is 1, and the root is 3, times, and then the next one is a square root. So I see that the power is 1, and now be careful here, because the root is this number right here. And remember, if we don't see a number there, that's a square root. And a square root means 2. All right, well, I know that if I have the same basis, I can keep the base, and I can add those exponents. So I'm going to add 1/3 plus 1/2. And when I get that, you could put that in the calculator, alpha y equals, right, 1/3 plus, and then alpha y equals again 1/2. And you will get 5/6. Oof, that looks ugly. I'm going to just rewrite that x to the 5/6. Oh, that looks prettier, right? There's your answer. Single term, rational exponent. 28 is similar to number 26 in the sense that it does say to explain, so you're going to have to use words. So what I notice here is they want cosecant, right? They want you to explain why cosecant is equal to 1/y. So I know that cosecant is a reciprocal trig function for sine, right? And then I think to myself, oh, wait a minute. They gave me this ordered pair down here, and isn't sine the y value? Right? The x is the cosine value, and the sine corresponds with the y value. So I would probably start by saying, well, the sine of an angle equals its y value, right? And since sine theta and cosecant theta are, remember what they're called reciprocal trig functions. Then the cosecant of theta, I'm just going to explain this first. If sine theta is equal to y, then the reciprocal trig function's value has to equal the reciprocal of this, right? So that would mean that it would have to equal 1/y. Okay, because y's reciprocal. is 1 over y. All right? So this question wants you to determine if this function, m of t, which is this equation right here, represents growth or decay. Okay. I personally would take this m of t equation and plug it into your y1. So I would take this whole thing right here and throw it into your y1. And when you do that, what's going to happen is you will see a graph that goes like this. This would be your m of t equation. Okay? So obviously, I see that as time goes on, my graph is decreasing. So you could say exactly that. I would show the picture, and I would say it represents a decay. I'm just going to abbreviate because as time goes on, m of t decreases. And that would show that you have a decay. Okay? The other thing that you could do is you could look at the table of values, and you'll see that as the x values increase, which represents time, your y values are decreasing. So that's another way to look at it. Then I would probably show, a table of values, but I like this way. That's just me personally. This question is tricky because you really have to read it through very, very carefully. So please, if you did not do so, then just make sure that you take a few minutes and stop me and read it. So basically what this is asking is a person more likely to jog if they have one sibling jogging or if both siblings jog? So you're kind of comparing one thing versus another. So for example, you're trying to figure out the probability that you will jog given that you have one sibling jogging, or are you more likely to jog given you have two siblings jogging? So this is really a given type of question, but you're comparing one to the other, all right? So remember the formula for given. So in this case, let's just look over here. It would be the probability of you jogging and having one sibling over the probability of having one sibling. Okay, so let's go up here. The probability that you jog and have one sibling would be this 416 right there. So the probability of jogging and having one sibling over the probability of one sibling. Okay? Well, like I said, the probability of jogging and one sibling would be 416 over all the people that have just one sibling. So that would be right there. You would, you would add those two numbers. Okay, and that ends up being 2,239. All right, now when I work that out as a decimal, that's 0.1857. 1857, sorry about that. Okay, so then over here on the right-hand side, let's look at this. So the probability that you'll jog given that you have two siblings that jog, well, first we're going to start with finding the probability that you jog and have two siblings. So student jogs, two siblings, that would be 400. So we have 400 in the numerator over, and then we have here the probability, the total in the denominator is going to be the probability that you have two siblings that jog. Okay, and that would be these two numbers right here added up. So that is going to give us, again, we're going to add those two numbers up, and that's 1,780. Okay, and when we work that out, that's 0.2247. So it's asking, are you more likely to jog if you have one sibling jogging or if both siblings jog? Obviously, we can look at this and we can say this number here is larger than this number here. So we're more likely to jog if we have both siblings jogging because 0.2247 is greater than 0.1857. Okay, now I am not going to be able to fit all of that in there, so I'm going to try to fit it up here. So we're more likely to jog, because it does say to justify your answer, more likely to jog if you have two siblings jogging because, sorry, my handwriting is nasty, because 0.2247 is greater than 0.1857. Okay, so in other words, the probability here is larger than the probability here. All right, so again, take the time to read this question. I am going to underline this portion right here, and that's half of the volunteers receive the drug, and I'm going to call that D, just for drug, okay? And then it also says the probability of getting well was 40%. I'm going to call that getting well W. So if you read the last sentence there, it says, what is the probability of a volunteer getting well given that they received the drug? Okay, just like the last question. So we're going to find the probability of getting well and receiving the drug over the probability of receiving the drug. Okay. So if you read the, what is that, the fourth sentence? 1, 2, 3, yeah. Okay. If you read that, it says the probability of a volunteer receiving the drug and getting well was 40%. So receiving the drug, which is D, and getting well, which is W, is 40%. Okay, so then that means that we can go right here and we can write 0.4. Now, then we want this to be over the probability of receiving the drug. Well, the probability of receiving the drug would be 50% because half of the volunteers receive that drug, and half would be 50%. So we put 0.5 right here, and then we can reduce that. It doesn't say how to leave your answer. The most exact form, obviously, is to leave something as a fraction, so that's what I would do. All right, so for this question, I would just, it says to verify, so I want to show that the left side is equal to the right side. So I think the only way that I would do this question, having to obviously, show work, would just be to do a whole bunch of double distributing. So remember that when you have a binomial that's squared, that means that you can write that term out, or you should write that term out, twice. Okay, so there is the left side of the equal sign. Let's do the same thing on the right. So x squared minus y squared, let's write that twice. And then 2xy, let's write that twice. Okay, so on the left side of the equal sign here, I'm going to double distribute. So there I'm going to get x to the fourth. Now here I'm going to get plus x squared y squared and plus another x squared y squared. So I'm just going to write 2x squared y squared. And then lastly, y squared times y squared is y to the fourth. All right, so let's do the same thing on the right side. So same deal, x squared times x squared is x to the fourth. Now again, here I'm going to get minus x squared y squared, and here I'm going to get minus x squared y squared. So that's really 2 of those guys. Okay. And then lastly, a negative y squared times a negative y squared is a positive y to the fourth, right? Negative times a negative is a positive. All right, and then these last guys here, those are monomials, so we're just going to multiply all our like terms. So 2 times 2 is 4, x times x is x squared, and y times y is y squared. Okay? All right, so if we look at this, let's just see if we have any like terms that maybe we can combine. I don't see anything here on the left side that has a like term, but I do see over here I've got a minus 2x squared y squared, and I have a positive 4x squared y squared. So those guys are like terms. So let me just underline those. And so in that case, we can add those like terms. So let's leave the left side for right now as, oops, sorry, that should be x to the 4th plus 2x squared y squared plus y to the 4th equals, now the right side, so let's bring down that x to the 4th, and let's add those like terms that I underline in red. So that's going to give me a plus 2x squared y squared, and then bring down that y to the 4th, and you can see that the left side equals the right. Yippee. Okay, so we verified it. We're done. Okay, there's a few ways to start this question. Basically, if you read the question, they want you to find h and k. Now, there's different ways to do this. I think what I'm going to do is leave that left side alone. So let me just bring down 2x cubed minus 10x squared plus 11x minus 7. And then on the right-hand side, I am going to just do some double distributing. Okay, so here I'm going to get 2x cubed. Then I'm going to get plus, right, hx squared. Then I'm going to get plus 3x. Then I'm going to get there, I'm going to get negative 8x squared. I'm going to get negative 4 hx, right? And then lastly here, I'm going to get minus 12. And then let's bring down that plus k. Okay? All right, so if we want the left side to equal the right, do you notice that what I have first here is the 2x cubed, and over here I have the 2x cubed. Okay, so then I look back over here and I notice I have a negative 10x squared. Well, I have an hx squared, but I have another x squared down here. So all I'm going to do is just move these next to each other, and hopefully you'll see why I'm doing that. Okay, so let me just bring down this left side. I'm not going to do anything to it. I just want to get the right side to kind of be in the same order as the left side. So what I mean by that is this. So again, like I said, 2x cubed comes first. Now I'm going to take all the x squared terms. So I'm just going to basically kind of put it in standard form if you want to think of it that way. hx squared minus 8x squared. So there's all my x squared terms. Now I'm going to take my x terms. So that would be the 3x and the minus 4hx. I'm going to write those down just next to each other. That's all. 3x minus 4hx. Okay, and then the last two terms are constants, so minus 12 and plus a k. Okay? All right. Now there's a reason why I did this, because if you look here at these two guys here, these are your x squared terms. And the thing is if I knew what h was, couldn't I take whatever that number is, subtract 8 from it, and I should get negative 10, because we want this left side to equal this right side. Think about that. So some number minus 8 we want to equal negative 10. Okay, so let me go back. I'm going to write that down. So I know that these two here, so hx squared minus 8x squared, I want that to equal 10x squared. Okay, so then I think to myself, well, what number can I put in for h that when I subtract 8 from it, okay, so what number can I put here that when I subtract 8 from it, I'll get 10? and hopefully you'll see what? What will you see? Well, the one thing you're going to see is that I forgot one tiny little thing. Ding, 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 ding. Oops. Hold on. Got to put on my marker again there. That should be a negative 10. So I'm going to rephrase what I just said. So let's try that again. What number, if I subtract 8 from it, will give me negative 10? Okay. So basically, what I would probably do is just add my 8x squared over, that's a plus sign, sorry, and add my 8x squared over, and you will see that hx squared would have to be negative 2x squared. So do you see now that my h has to be negative 2? H has to be negative 2. Okay? Now another way you can look at it is if you're good with your positives and negatives, let's go back up here. I said to you that negative 10 has to be the number in front of the x squared. So what number can you put here and add a negative 8 to it and get negative 10? Well, a negative 2 and a negative 8 gives me negative 10. So that's how we find h. Now we're going to do the same thing in terms of finding k. Okay, so I notice that k is down here, and it's just a constant. In other words, there's no x term next to it. So I would group these two guys together, and I know that these two guys should equal the constant that's over on this side. Okay, so similarly, let me use a different color so that you can kind of see it. So this negative 7 should be equivalent to those two added together. Okay, so negative 7 is equivalent to negative 12 plus what number? Okay, now you might be able to figure it out right now and say, oh, it's 5, but if not, get the k by itself. Just good old-fashioned algebra. Go like that. Negative 7 plus 12 is 5, and there's your value for k. All right? After reading this question, it asks which one follows an arithmetic pattern. Now, you're going to have to look at the graph because I don't have the graph up there. But an arithmetic pattern would increase by the same amount every single time. So that would be the graph that has the dots on it, which would be Jillian's plan. Okay, so you would say then, whoops, you would say that it would be Jillian's. Holy mackerel, there we go. Jillian's, because it's linear. Now, because it's linear, that means that it's increasing. Sorry, at a constant rate. There you go. All right, the next part, it says write a recursive definition to represent the number of miles run each week for the duration of, in this case, Jillian's plan. Well, if you look at the graph at week 1, which would be the first dot, you can see that it corresponds to 10 miles in that week. So your a sub 1, oops, is going to be 10. And then remember, the other part of the recursive formula is a sub n equals a sub n minus 1, and then in this case plus d. So in other words, what it's increasing by each time. And if you see, the next dot goes up to 11 miles at week 2. So it went from 10 miles in week 1 to 11 miles in week 2. And then from week 2 to week 3, it goes from 11 miles to 12 miles. So that's increasing by 1 mile per week. So that would be your recursive formula. For the last part, they want an explicit formula. So if you look, oops, did it again, sorry. So if you look right here, they're asking for an explicit formula in simplest form. So remember, for an arithmetic, the general formula is a sub n equals a sub 1 plus n minus 1 times d. All right, well, let's write a sub n equals. Now remember again, In this case, they're starting at 13 miles. So that would be our A sub 1 plus n minus 1. And then again, we're still using Jillian's plan, and that's going up by 1 every single time. So our D would be 1. Now, normally we could leave it like this, but it does say in simplest form. So if it says in simplest form, let's keep going. So we have A sub n equals 13 plus, now 1 times n minus 1 is just n minus 1. So then that's going to end up being 12 plus n equals A sub n. For this question, I like to write down everything off to the side. So they tell you that the amplitude is 2. So I'm going to write A equals 2. They told you the midline is y equals negative 3/2. Now remember that midline, and that is a negative, sorry, is also equal to the vertical shift. So let's not forget that. They tell you that the period is 2 pi. That's how long it takes to complete one full curve. So that means the frequency is going to be 2 pi over the period. And since the period is 2 pi, that's 2 pi over 2 pi, which is 1, which means you'll have one full curve from 0 to 2 pi. All right, let's go a step further. So if I wanted to find the maximum, remember that the maximum is vertical shift plus the amplitude. So in this case, your vertical shift is negative 3/2, and your amplitude is 2, so your maximum is 1/2. All right, if I want to find the minimum, I'm going to do the vertical shift minus the amplitude. Now, I'm not going to write that down just because I'm running out of room. So the vertical shift, which is negative 3/2, minus the amplitude. So then we know that the minimum is going to be negative 3.5. So what I'll do is, I know I need to go down to negative 3.5. That's my minimum, and my maximum is 1/2. So probably what I will do is I'll go like this, and I'll make that 1, and then let's try to make that equivalent to 3, 4. So that'll be negative 4, negative 3, negative 2, and negative 1, and obviously that's 0. Okay, well, we know that the period is 2 pi, so let's make 4 little slashes. And we'll do pi over 2, pi, 3 pi over 2, and then 2 pi. Okay. I always like to do the midline first, so let's look at the midline. The midline is at negative 3/2, which is negative 1.5. So that means my midline is right here. Okay, and it doesn't talk about any horizontal shift, so then I know that if I wanted to write the equation of this graph, not that it asks for it, but remember any sine or cosine curve will always take the form of y equals a sine b x, and in this case I have a shift vertically, so the plus, and let's just call it d. Okay, so in this case I know that my amplitude is 2. The period of my graph, the frequency of my graph is 1, so my b would just be 1, right? And then I shifted down 3/2, so minus 3/2. Now the reason why I'm telling you this is, let's look at this equation and compare it to part B. And then you'll see in part B, which I'll scroll down in just a second, the difference between what I just boxed off in green here and what you have in part B is that we don't have parentheses here. So in part B, there was a horizontal shift. Compare part B, you look at your paper, and look at what I'm pointing at right here. In part B, you have an amplitude of 2, and you have a vertical shift down 3/2. What you don't have is that negative pi over 3, which I'm going to talk about right now. So what that means then is, since you have a minus pi over 3 here, remember that represents a horizontal shift. So explain the differences. The difference would be here in part B that we have a shift. And remember, it's always the opposite direction of whatever the sign is. So the sign between the x and the pi over 3 is minus. So we're actually going to go in a positive direction. So we have a shift right pi over 3 units. Okay? In part A, and I did say this, but I'll repeat myself. In part A, there is no horizontal shift. And there you go. For this part, they talk about, and you can read the question, they want you to be 95% confident of their results. So it says that right here, 95% confident. Now, if I look up here, I see that they gave me the mean and the standard deviation. So remember, when we have 95% confidence, that would be the mean plus or minus 2 standard deviations, okay? And if you read the question, it says determine an interval. So basically, we're going to just plug in what the mean and the standard deviation are and go from there. So the mean, if you look at the top, is 0.506. So I'm going to plug in 0.506 plus or minus 2 times the standard deviation, which is 0.078. So we're going to do 0.506 plus or minus. We're going to double that standard deviation, which is 0.156. And then from there, we're going to do 0.506 minus 0.156, which will give me 0.35. And then we're going to do 0.506 plus 0.156, which will give me 0.662. So we know that the interval is within those two numbers. Now it does say to round to the nearest hundredth, so let's just kind of take care of that. So we know that the numbers will be between 0.35 and 0.66, and that will give us our 95% confidence interval. For the second part here, you have to read through it, but it does say that the proportion of customers who prefer the new procedure is 32.5%. And they want to know, the dealership decides not to implement the new check-in procedure based on those results and use statistical evidence to explain this decision. So 32.5%, I wrote it down here just because a lot to write all at once, is 0.325. And if you look at 0.325, that number, that value, is not within this 95% confidence interval. So that's what I wrote here. It's not within the 95% confidence interval of 0.35 to 0.66. So that's really not likely to occur. Okay? So that's what we would call statistically significant, being outside that 95% confidence interval. So the people preferring the new check-in procedure is low, and it wouldn't be beneficial to implement the plan. All right, so for this question, they basically just want you to find out, solve for t, when s is equal to 0. Well, here's s right here, so we're going to replace that value with a 0. So 0 is equal to the square root of t minus 2t plus 6. Now, if you remember, with any kind of a radical equation, we try to get the radical by itself, so we try to isolate the radical. So I'm going to bring the 2t over to the other side over here. That's a plus 2t, by the way. Minus a 6, minus a 6. All right, so that's gone and that's gone. So now we have 2t minus 6 equals the square root of t. Okay. Okay, that's an equal sign, sorry. All right, so we've isolated the radical. Now we try to get rid of that radical. So the way we're going to go about that is by squaring both sides of the equation. So we square both sides, and that will cancel out the radical. Now on the left-hand side, I have a binomial, and that binomial is squared. So remember that means 2t minus 6 times 2t minus 6. We write it twice, and we're going to double distribute. And then on the right-hand side of the equation, we're just going to get t because the radical and the square root canceled each other out. All right, so if we double distribute here, we're going to get 4t squared. Then we're going to get minus 12t minus 12t, so that's going to be minus 24t plus 36 equals t. Okay? All right, so then let's subtract this t over, get everything to one side, set it equal to 0, and see if we can factor. So we have 4t squared, that's going to be minus 25t plus 36, and then we're going to have equals 0 because those guys will cross out. All right, so now what we want to do is we want to try to figure out how we can factor this. We could also do quadratic formula, that's an option too. I'm going with factoring though. All right, so let me just change my colors here. So what I'm going to do is I'm going to do the rainbow method. So I'm going to figure out what that multiplies to. And that actually multiplies to 144. So I'm figuring out what multiplies to 144 and adds to negative 25. Now remember, you can go into your calculator, go into your y1, and do 144 divided by x. And then you can see all the factors of 144 that might give you 25. All right, so when you do that, you should end up with, let's drop the first term down. Remember, we always do that. And we drop the last term down as well. And then those two numbers, oh, what is going on with my equal sign? I'm sorry about that. That multiply to 144 and add to negative 25 would be a negative 9t and negative 16t. And then remember, we group and we group. All right, I'm going to bring this up over on the other side here because I'm running out of room. So I'm going to take the first two things, and I notice that they have a factor of t, so let me factor that out. And I end up with 4t minus 9. Then I take the second group there, and I see that they both have a negative 4. So I'm going to factor that out, and I'm going to end up with 4t minus 9. And that's how I know I did it right, because those two parentheses should end up being the same if I've factored correctly. So then I write t minus 4 and 4t minus 9. And let's set that equal to 0. And then we're going to do our little t chart here. And we're going to get t equals 4. And then we're going to get t equals 9 over 4. Now, it is important anytime that you have a radical equation that you check your two solutions back in this original equation, or let's go back down here actually, in this original equation because it's set equal to 0. So I'm going to take the square root of 9/4, which you can do that in your calculator, but it is 3/2, minus 2 times 9/4, and then add 6 to that. Okay? So I picked the hard one to do first. So like I said, we've got, let's just extend this down, 0 equals the square root of 9/4, which I said is 3/2, minus 2 times 9/4, right? And then plus 6. And let's see if we get 0. So I get 3/2, and then I'm going to get what? I'm going to get minus, that will be 9 over 2 plus 6. So 0 equals, that's negative 6 over 2 plus 6, which is negative 3 plus 6. And that does not equal 0. So I know that that is an extraneous root, and that will not be a solution. Now I'm going to do the same thing with t equals 4. And again, let's go back to the original equation right here, and let's plug it right into there. Okay? All right, so I'm going to try to squeeze this in. So 0 equals the square root of 4, which I know is 2, minus, I have 2 times t, so that's going to be minus 2 times 4, which will be minus 8, right? And then plus 6. So then I have 0 equals negative 6 plus 6. Woohoo! Well, that works, doesn't it? So we know t equals 4 is a solution. All right, so for this last part, they want to know how much faster the tidal wave traveling after 1 hour than 3 hours. Oh, I'm sorry, how much faster was the tidal wave traveling after 1 hour than at 3 hours? So I'm just going to find how fast it was traveling at 1 hour, how fast it was traveling at 3 hours, and then we're going to kind of compare. So I'm just going to plug in 1 for t. Okay, so s equals, now the square root of 1, right, which is just 1, minus 2 times 1 plus 6. So I've got s equals 1 minus 2 plus 6. And that is going to give us 5. So that is how fast the tidal wave was traveling at 1 hour. Now let's plug in 3 and see what we get. So here I'm going to do s equals, now I don't know what the square root of 3 is, so I'm just going to leave it for right now, minus, now 2 times 3 is 6, plus 6. Well, so those guys are going to cross off, right? So s is equal to the square root of 3. Now you can plug in the square root of 3 into your calculator, and you'll see it's roughly 1 point something or other. So to determine how much faster the wave was traveling after 1 hour versus 3 hours, I just would simply do 5 minus the square root of 3. And that ends up giving me 3.2679. So that's how much faster it was traveling after 1 hour versus 3 hours. However, go up and read the top of the page. Number 37, the very first sentence. Read it. It says the speed of a tidal wave s, here we go, in hundreds of miles per hour. So this answer right here represents hundreds of miles per hour. So what I need to then do is I need to take that value and I need to multiply it by 100. So that's going to give me 326.79, right? Now, it says to the nearest mile per hour. So nearest mile per hour would be the ones place. So then if we round that, that's going to round to 327 miles per hour faster at time 1. There you go.